Okay, today we're still looking at square roots. Kind of looked at what they were yesterday. We just looked at perfect squares today. So now let's review again how to do the square roots. It's just like the opposite of squaring something. So you have to ask yourself, okay, if the square root of 49, what would I square to get 49? Well, I would have to do 7 times 7 to get 49. So 7 squared is 49, so the square root of 49 is 7. And that's because 7 squared equals 49. But there's actually another solution, because let's think about it this way. Again, I'm looking for the square root of 49. So I need something that I can multiply by itself to get 49. Well, 7's not the only answer. You also could have negative 7. Because if I do negative 7 times negative 7, don't I still get 49? Okay. So that's actually an answer to that problem as well. So square roots actually have two answers, because there are two things that you could square to get any number. So if I'm looking for the square root of 49, well, that could be 7, or it could be negative 7. So the next thing we have to learn is our notation. Okay, normally we just see the symbol like this, just the radical by itself. And when you do, that means that it only wants the positive solution. So if it looks like this, it only wants the positive answer. This would actually be incorrect, because it says I want the positive answer and this gives the negative answer. Okay, so if it just has the radical, then it's only looking for the positive answer. Okay? Then we also have the symbol that looks like this. It's a radical with a negative sign in front. And as you can probably guess, yes, that means it wants the negative answer. So if this had a negative sign in front, then negative 7 would be the answer it was looking for. And then we have one more symbol, the plus or minus square root. Okay? And this means that it wants both answers, the positive and the negative. Okay? So notice, and I did this plus in blue because it's not really there. Okay? These are in black because you'll see those. You won't see the plus sign if it's by itself. If it's a symbol by itself, it means it wants the positive answer. Okay? So if you see this sign, it means just the positive answer. If you see the one with the negative, it means just the negative answer. And if you see the one with both symbols, then it means it wants both answers. Okay? So you will only have one answer unless it has the plus or minus sign, in which case then you'll put both answers down. Alright, now we also need to look at a different scenario. Okay, and that's when you have the square root of a negative number. Now notice, this time the negative isn't on the outside. If the negative is out front, it just means we want the negative answer. The negative on the inside means you're actually taking the square root of negative 9. Now let's think about that for a second. You need to find a number that you can multiply times itself, and you get negative 9. Okay? There is no number, because if you square any number, it becomes positive, because a negative times a negative is a positive, or a positive times a positive is a positive. So there is no real number that gives a solution to this equation. Okay, so that's the answer. No real number. So if there's a negative inside the radical, under the radical, then the answer is no real number every time. Okay, that's just kind of a special case. And that's because anything you square becomes positive. So there's no way to get any negative number. So you can't take the square root of a negative number. Okay? So, to recap again, if there's no sign in front, it wants the positive answer. If there's a negative sign in front, it wants the negative answer. If you have the plus or minus both signs in front, then it wants both answers. And if there's a negative underneath the radical, then there is no answer. So you write no real number. Okay, makes sense? All right, good. Now, we're going to try some. So you're going to evaluate the square roots. Alright, so you got 6 square roots. I'll give you a minute to go ahead and write down the answer to each of them. Okay, so looking at number 1, again, a square root, you just ask yourself, what times itself gives me 81? Well, 9 times 9 gives me 81, so that answer is 9. And since there's nothing here, it wants the positive answer, so that's positive 9. Now for number 2. The square root of 25. Well, 5 times 5 is 25, so the square root of 25 is 5. But it tells me that it wants the negative answer, so I'm going to take that negative and put it in front of the 5. So the answer to the negative square root of 25 is negative 5. Alright, same thing for number 3. I look at the square root first. The square root of 4 is 2, and it tells me that it wants the positive and the negative, so I need the positive and the negative. So basically, all you're doing is, if there's a symbol or a sign in front of the radical, then you put that symbol or sign in front of your answer. There's a negative there, I put a negative there. There's a plus or minus here, I put a plus or minus here. That's the simplistic explanation of it, because that's the answer it's looking for, so that's the answer you give. So on number 4, square root of 121, well, that's 11, because 11 times 11 is 121. And since there's no sign in front, I leave no sign, because that means positive, and so does that. Alright, now number 5, the square root of negative 16. Well, the square root of 16 would be 4. But this negative this time is on the inside of the radical. It's underneath the radical. So we can't take the square root of a negative number. So the answer is no real number. Okay? Doesn't matter what the number is. If there's a negative underneath the radical, then the answer is no real number. Okay, then number 6. The square root of 49 is 7. And since there's a negative in front, I put it in front of the 7. It wants the negative answer, so the answer is -7. So, as you can see, like I said, you're just taking the square root of whatever it says to take the square root of. Square root of 25 is 5. Square root of 121 is 11. Square root of 4 is 2. Okay, and then if there's a sign in front of the radical, you put it in front of your answer. Okay, now, but here's the only one that's different. If there's a negative under the radical, then it's no real number every time. Now, we just talked about perfect squares, and finding the square root of perfect squares is pretty easy. But every number is not a perfect square. So, what do we do to find the square root of something that's not a perfect square? Okay, well, we have to estimate it. We have to use our perfect squares in order to estimate what the square root is going to be. Okay? I don't know the square root of 10. I mean, can you think of something that I can multiply times itself to get 10? Nope, me either. So, what we have to do is we have to come up with perfect squares that are around 10. Okay, so I know that the square root of 9 is a little bit less than the square root of 10, right? Because 9 is a little bit less than 10. So this has got to be smaller than this one, right? And I know that the square root of 16 is a little bit bigger than the square root of 10. Right? Because 16 is bigger than 10. Now, why did I pick 9 and 16? Well, I picked 9 and 16 because they're perfect squares. See, I know that the square root of 9 is 3. And I know that the square root of 16 is 4. So now, I know that the square root of 10 has to be somewhere between the square root of 9 and the square root of 16. Which means the square root of 10 has to be somewhere between 3 and 4. See, I use my perfect squares that I know to find approximately where something that's not a perfect square would be. So, but I also see that this 10 is a whole lot closer to the 9 than it is the 16, right? So it's obviously going to be closer to the 3 than it is the 4. Okay, so I can erase that, and let's say that I guess that it's 3.1. Because since 10 is closer to 9, I made my answer closer to 3. Okay, so I guess 3.1, and that's my approximation. That's my estimate. This is how we estimate square roots. You find the square root, you find the perfect square that's smaller than it, and the perfect square that's bigger than it. And then you know it's got to be somewhere between the two. Okay, now, if I put this in the calculator, the square root of 10 is 3.162277, and it keeps going on. So you can see if I rounded this, it would be 3.2. So the calculator gave me 3.16 and stuff, and my estimation was 3.1 without a calculator. That's pretty good. Okay? So, when you estimate these, they don't have to be exactly what the calculator says. They're not going to be exactly what the calculator says. Because these numbers go on forever. Okay? They're irrational. They don't repeat. They don't stop. So you're not going to get exactly right. What you're trying to do is get close. So that's why you can just find the perfect squares on both sides and then kind of see which side it's closer to and then just guess. That's honestly all we're doing is an estimate. Okay? So, let's see if you can estimate some square roots. Okay, now as you can see, none of these square roots are perfect squares. Right? But you don't need a calculator to do these. In fact, you're not allowed to use a calculator to do these. Okay? So, I'm going to give you a minute. Use your perfect squares to try to estimate these square roots. Alright, so looking at the first one. The square root of 40. We don't know what the square root of 40 is, but we know some perfect squares that are around 40, because I know 36 is a perfect square, so the square root of 36 would be a little smaller than the square root of 40, and the square root of 49 would be a little bigger than the square root of 40. Okay, well, square root of 36 is 6, square root of 49 is 7, so I know I'm going to be in between 6 and 7. So 6 point something. Now, the 40 looks a little closer to the 36. It's only 4 away, whereas it's 9 away the other way. But still somewhat in the middle. So I'm going to guess that that's 6.3. Okay, now if you put 6.2 or 6.4, that doesn't really matter. Okay, it's an approximation. As long as you got in between 6 and 7, then really that's a good approximation. Okay, but you should at least be a little closer to 6 because it's obviously a little closer to 36. And that's all you have to do. Okay, so 150. Okay, what perfect squares do we know around 150? Well, we know 144. Okay, and we know 169. The square root of 144 is 12. The square root of 169 is 13. Now, I will also go ahead and note this, that when you're doing this, these two numbers should always just be one apart. See, 12 and 13, 6 and 7. Okay? If you get something like 12 and 15, then you miss some of your perfect squares. You have to have the closest perfect squares. Okay, so these always have to just be one number apart. Okay, they can't be 2 or more. It's got to be 6, 7, 12, 13, 4, 5. It's got to be something like that. Okay, it can't be separated apart. Okay, now I can see that the 150 is closer to 144. It's only 6 away from that. It's 19 away from 169. Okay, so I'm going to say it's 12.2. Okay, again, really doesn't matter as long as you do 12.1, 12.2, 12.3, any of that's fine. Okay? Alright, so now let's look at number 3. Number 3 has a little bit of mix of what we just learned too. Okay, but let's just focus on the square root for now. Okay, the square root of 93. Well, I know that's in between the square root of 81 and the square root of 100. Okay, and I went ahead, since this one has a negative sign, I put negative signs on these two. Okay, and negative square root of 81 is negative 9, and negative square root of 100 is negative 10, right? So I know I'm going to be in between negative 9 and negative 10. Well, 93 is pretty close to the middle, but a little closer to 100 than 81. So I'm going to approximate that at negative 9.6. And then number 4, same thing. But, let me look at number 3 again for a second. So notice, it had a negative, so my answer was negative. Same rule as before. So if it had a plus or minus out here, it would also have a plus or minus here. Same rules. Alright, so number 4, square root of 22. Well, the two perfect squares I know are 16 and 25. and that's 4 and 5. So I know I'm in between 4 and 5. Okay, well 22 is closer to 25, so I'm going to be closer to 5, so 4.7. Okay, and really if you pick 4.6, 4.7, 4.8, 4.9, any of those are fine. Okay, because it's just an estimation. But notice, we're estimating square roots that are not perfect squares anymore, and we're doing it without a calculator, just by using the knowledge of the perfect squares that we know. Okay, now you need to put this on your paper. You're going to need to make it pretty large. This is going to be our perfect squares number line. Okay, we're going to put all of our perfect squares onto a number line. Now, my number line, I'm going to count by tens. Okay, so you can see every fifth one is 50, because I've got to count pretty high to get all my perfect squares on there. So this number line is counting all the way up past 400. Okay, now here's what you have to do. You have to put a mark on your number line where every single perfect square is, and you have to say what it is. Okay, so example, 1 goes right here, and 1 squared is 1. That's why 1 is a perfect square. Then I also have 2 squared is 4, so I put a mark at 4. So you can see a lot of them are going to be bunched up here at the beginning, but then they're going to kind of spread out. Well, what's the next perfect square? It's 9. Okay, because 3 squared is 9. The next perfect square is 16, because 4 squared equals 16. Then 25, because 5 squared equals 25. Okay, now this may be kind of hard to see if you're not looking on your own computer, but you know all these perfect squares, and you know where those numbers go on the number line, so you can build this. You can even go ahead and get ahead of me, okay, because I'm just going to go down the line, down my perfect squares. Okay, so the next one is 36. 6 squared equals 36. 49. 7 squared equals 49. Then 64. 8 squared equals 64. 81. 9 squared equals 81. 100. 10 squared equals 100. Okay, so we've done our first 10 perfect squares. Okay, 121. See, they're starting to get spread out here. 11 squared equals 121. 144. 12 squared equals 144. 169. 13 squared equals 169. Then 196. 14 squared equals 196. And 225. 15 squared equals 225. See, these are getting much more spread out now. Okay, because each time it gets more bigger than it did last time. Okay, then 256. 16 squared is 256. And 289. 17 squared equals 289. Then 18 squared equals 324. Then 19 squared equals 361. And then 20 squared equals 400. Okay? Now, that's all the ones you have to know for our quiz tomorrow. I mean, later this week sometime. Alright, so if you've got all of this on your number line, and you know all of this, you should be just fine for your quiz. But more than that, if you know all of these, then you can find, or estimate any square root you need. Okay, now I'm also going to, just because I got more room on my number line, put 21 squared equals 441. That's all that will fit on my number line. Okay, but see, now you can use this number line. If I need to find, let's say, the square root of 300, well, I know that's going to be in between 289 and 324, right? So that's going to be in between 17 and 18. A little bit closer to 17 maybe. So maybe 17.4. Okay, so I can use this line to approximate any square root, basically up to 400. Okay, so this can be a very useful tool when you're trying to calculate and approximate square roots. Okay, and I would use this when you're working on your homework. You can use this also to help you make sure that you know all your perfect squares for that quiz.